going to spread this around to the other 30, 40, 50 maybe people that haven't made it for whatever reason. And right, we're off and running. So Valentin Suter, IoT practice here. Take the microphone. Let's hear all about it.
Okay, thank you, Mark. So I'm Valentin. I represent IoT practice, offering support globally for sales opportunities in pursuit. I also explore IoT partnerships and try to turn POCs in IoT accelerators. I'm having a mainly technical focus, but I keep a close eye on our revenue and gross profit margin targets. I'm based in Timișoara, Romania. I have recently joined Nest 3 months ago, coming from Honeywell, the smart energy line of business. I come from the electricity side of it, where I was responsible for developing electricity meters, the firmware, the hardware, the mechanical side, and also the end-to-end solution testing, including electricity meters, gas meters, communication hubs, in-home displays, and the head-end system software. Big customers that we addressed among the entire energy food chain, I can tell British Gas, Scottish Power, I think E.ON, Enedis in France, Enexis in the Netherlands, DEVA, that's Dubai Electricity and Water Authority, Brussels Airport, and so on. So we basically addressed power generation utilities, transmission and distribution customers, and also the end users, the consumer and industrial customers. So yeah, that's basically my background. And turning back to the presentation of today, let me try to share something. You let me know when you see it.
Not yet, but we did practice, so I'm confident.
Okay, let me get back to this. Share. I think this one.
Yeah, we're loading now. Yeah, you're on screen.
Okay. So coming back to this presentation, yeah, it's intended to raise automotive awareness for our customer-facing colleagues and be baseline for future material targeting automotive customers. We had a good session last week. Sales colleagues came back saying, hey, we didn't know we're so deep into automotive. Let's do some sales together. And this is exactly what we wanted. So throughout this presentation, we will be referring to two disruptive technologies. That's autonomous driving and electric vehicles, where directly or indirectly, Nest is bringing its contribution. Okay, switching slides. Did it do it?
Yes, yeah.
Okay, good. So here I want to say that the automotive industry is going through a radical change, one of the most radical changes in its history, and that is the autonomous driving race, where automakers are competing already. This is a revolutionary change, but the adoption is evolutionary. So just to be synced and aligned among ourselves, I'm going to quickly go through these various levels of vehicle autonomy as defined by the Society of Automotive Engineers. So level 0, that's the old days. Driver does everything at all times, doesn't get any assistance from the vehicle. In level 1, the driver gets assistance either for speed or for lane positioning. Level 2 is the most advanced autonomous vehicle on the streets today, offering you assistance for speed and lane positioning for both of them. In level 3, the vehicle is semi-autonomous and has full control in some situations, but it turns back to the driver when it needs assistance. And these vehicles are today in production, but they can't hit the road until the legislation is changed to allow for that. In level 4, the vehicle has full control at all times over the vehicle, and it turns back to the driver when his or her intervention are desirable, but it does not count on it. While in level 5, the vehicle can operate with or without occupants. In level 4, these vehicles might appear in the next 5 years or so. Technology is ready for testing, but at a working level, but validating the software might take years to get into the reliability and safety targets. The main challenge for both level 4 and level 5 is operating vehicles without restrictions in any environment, like unmapped areas where lanes are not seen, like covered by snow or inexistent, or in places where the infrastructure is really complex and not everything could be foreseen in the training stage for that. In level 5, there are daunting challenges like object analysis, detecting objects and understanding scenes, decision-making systems which needs to be trained, and also fail-safe mechanisms which allow a car to fail without putting its passengers in danger. All right, promises and hurdles. We know that every year 1.25 million people die on the streets, and more than 50 million are hurt in car crashes, and in more than 90% of the cases, the human error is to be blamed for that. And the promise of the autonomous vehicle is that this problem will be eradicated. Now, safety experts fear that that won't happen from the very beginning. In level 3, for instance, the vehicle turns back to the driver requesting assistance, but the driver might have lost situational awareness, doing texting, writing an email, or such. And at higher speed, to get that situational awareness back takes some time. So that's where a problem could be. Now, among promises, other areas where we'll see improvement, it's lower energy consumption, lower pollution, lower transportation costs. Among challenges, you have a speeding car, crossing a red light, the intersection coming in front of you. What do you do as an autonomous vehicle? Do you hit it, killing the passengers? Or you head for the crowded bus station nearby? So there are many ethical questions that need to be answered before really deploying level 4 and level 5 vehicles on the street. There's also the cybersecurity question. I mean, there are fears that automakers have focused on different areas of technology and leaving cybersecurity behind. And so that needs to be addressed as well. And of course, laws, licensing, and regulations. And here we can tell that, for instance, in Germany, they are working to change the old 1968 Convention of Vienna to allow level 3 and 4 of autonomous driving on the streets. Moving further to the electric vehicles.
Hey, Valentin, can I just jump in 1 second? Just those 2 scene setting slides you've given us. I mean, I might move on to it in a minute, but when you're going through the 1 to 5 range, even, is it worth us being able to weave in right there where we see our work in auto leave and ADAS and whatever in the kind of 2 and 3 area? Where's the next play in this on that slide?
Absolutely, we have been contributing to level 1 and level 2, but we're also focusing on areas, and I will mention that later on during the presentation, right, which are absolutely required for the autonomous driving race, like the intelligent brain, where we attempt to do scene understanding, traffic signs recognition, highway path planning. So all these are basically preparing for level 3 and even level 4. So although those vehicles are not yet on the streets, we do work preparing the ground for those vehicles with our Autoliv work. Okay?
All right. Yeah.
Sure. Okay. Going now to the second disruptive technology that I mentioned at the very beginning, the electric vehicles. I wanted to say that an EV has a lot less moving parts than a conventional car, ICE car, and it doesn't need to have expensive exhaust systems, radiators, fuel injection, many other parts that are needed in an EV. With just one moving part, the rotor, they are really simple and very strong. Aside from perfecting the battery, they're far easier and cheaper to build. And that is why this makes, we're having a level playing field, opening the door for new competitors over there. We just need to maintain the brakes, the suspension, the tires, and that's about it. You eventually need to change the battery, and that is a problem among the challenges over there, the battery recycling point. A big battery waste problem leading, can occur, leading producers accountable for the collection and recycling of spent lithium-ion batteries. Now, but these electric,
Valentin, it is possible though that as it matures, the battery might be something you swap at a garage for another charged battery, and it might not become the problem of the consumer there, right? It's just the industry has to take care of the battery.
That's exactly what they say today, that the car producers will be made accountable for collecting and recycling these spent lithium-ion batteries. Although it doesn't mean that, a battery, if a battery is not good for automotive anymore, it can be used for energy storage, for instance, for your house. I mean, you can still continue to use that for a different purpose. That's what they say also, and not recycle it right away. Okay, so about the impact on global energy systems, we are probably not going to see power demand crisis because of all the electric vehicles being plugged in to charge, but we'll see most probably a different load profile, a different demand profile change. So that because the peak hours are typically the ones when today the people are also putting their EVs to charge at home. If incentives are being brought so that time can be shifted at nighttime when the tariffs are cheaper, that would solve the situation. Okay. The importance of software has grown, but so did the complexity. About 8 years ago, there were cars with about 10 million software lines of code. A year ago, there were cars with about 150 million lines of code, a factor of 15. So imagine the complexity, and that can be seen in the large number of vehicle recalls, showing that the technology has not really been 100% tested. It's clear that with this increased functionality being implemented, you can't just continue to use the old architecture. So new ones are being designed. Here we refer to McKinsey research data, and they are projecting that today's architecture will change into a service-oriented architecture based on generalized computing platforms. And deep down here at sensors level, the ECUs will see an increasing consolidation. The middleware, where the operating system of the car is being placed, will make possible to reconfigure cars, enabling the installation and upgrade of their software, enabling abstraction, virtualization, distributed computing. Now, moving higher, the artificial intelligence and advanced analytics will analyze data for real-time decisions and autonomous driving. We will see an increase in the number of applications being developed by OEMs and third party. And definitely cars will use the cloud to combine onboard information with offboard data which is not personal or safety related can be safely processed into the cloud for giving additional insights to the users. The automotive Ethernet will rise and become the backbone of the car, because today the current internal networks inside the car are not able to handle the required data rates and also the functionality which is needed. So just to name a few is the audio-video bridging and time-sensitive networks. Digital security requirements will definitely change from an access control only to an integrated security concept to anticipate, avoid, and defend against cyber attacks. Now, what
Hey, Valentin, sorry to keep interrupting. That was fascinating.
Something
you said right at the start, right? The number of service recalls. I hadn't really thought before, but are service recalls happening now for software rather than something gone wrong with the car? And then where does the future lie with pushing out over-the-air updates so that you don't have to bring the car in?
Well, that is an integrated concept of the connected vehicle. So the middleware will allow for that over-the-air updates. And the security concept that I have just mentioned before will make sure it is the right image, the secure boot image that needs to be and will be flashed and upgraded, not a hacked one.
Right, and this complexity of onboard versus cloud is, like, to me, I'm a bit of a layman here, the very definition edge computing, isn't it? How much you keep on board and how much you transmit to the cloud at these data rates.
Absolutely. So you need to have the real-time processing kept on the edge while doing, other processing, like I said, which is not safety critical or personal up there in the cloud. So that's where this is envisioned to happen.
Right.
Okay, so let's continue with what we as NES are doing. And yeah, we say that we claim that we're the digital engineering partner for automotive companies and OEMs having domain knowledge and competencies in key areas like active safety, drive control, and connected vehicles. Now, at NES, like I said, we focus on elements absolutely required for the evolution of the automotive industry. We do the digital eyes for viewing intelligence, the electric drive to deliver the electric engine power to the road surface for electric vehicles. We do the connected vehicle for next generation navigation, and also the intelligent brain, where we deploy machine learning techniques for vehicle and driver safety. So what do we actually do here? Digital eyes relate to ADAS, Advanced Driver Assistance Systems, and they translate into one: ECU, embedded software development, integration, and testing. The electric drive relates to the powertrain of the electric vehicle, but it translates into the same one: ECU development, integration, and testing. The connected vehicle, for the connected vehicle, we develop road mapping and navigation system software. For the intelligent brain, we use neural networks to do image interpretation, attempting to figure out road semantics and augment human senses. And in addition, although this is not a direct automotive offering, with the anticipated huge flow of data, of vehicle-related data, we offer our big data and analytics expertise. So where does it all fit together into the architecture that I have previously shown? Well, the cloud, at the cloud platform layer, we address it with the big data and analytics, and also the connected vehicle. Big data and analytics, we combine in-vehicle data with cloud data to derive meaningful insights. The connected vehicle contributes with road mapping and navigation system. We find the same connected vehicle product at the applications layer for edge computing. The intelligent brain fits in the artificial intelligence layer. And deep down at sensors, at ADAS level, we have the digital eyes. But not so obvious, but equally true for the connected vehicle, which adds another dimension to the ADAS functionality. And last but not least, the electric drive at the power system level of the electric vehicles. Okay.
Hey, Valentin, Sorry.
Yes.
So one of the things that we've been talking to a lot of companies around, and Mark, I'm thinking about Ryder, Oshkosh, companies like that, is fleet management, which from a connected vehicle and cloud standpoint is another layer above this. We're not just talking about the logistics around fleet management, but we're talking about integrating things like condition-based maintenance into what they're doing with fleet management. Is there any way we could well, first let me ask the team, do you think that's a good thing to weave into the story? And if so, how would you see it fitting in, Valentin?
Well, we have on our desk 4 slide decks in the IoT practice, which we would like to release and for our colleagues to further use them. One of them is the core automotive. And this is basically what you will see today. The second one is going to be the smart mobility, where we will have, we will be addressing, opportunities like fleet management, like VIX, that's intelligent transportation, that is the Flowbird. I think that's about the same. And also here, because here is not doing core automotive offering. What you see here is directly related to the vehicle itself. It's basically under the hood. So you will see the connected vehicle under the hood, right? Doing, supporting the ADAS, the ECU under the hood as an additional sensor. You see the digital eyes, which are the cameras installed in the car, and giving you, raw data for doing further processing, recognizing images. So, okay, this is pure automotive. The second is smart mobility. Then we will have smart living, where we will feature use cases like Geo, that's smart homes, Honeywell, which will feature electricity metering, utilities, and so on, and then TiVo also. And then we will have, let me see which one, and smart machines. Yeah, that's the last one. Actually, we're going to present that on January the 10th next year, where we will be focusing on smart machines only, addressing the IIoT, seeing what the difference between IoT and Industry 4.0 is. How does this condition-based maintenance represent only a little piece of the maintenance itself? That CBM is just so very little part of the big contribution that we brought to solar turbines. Among 100 applications, CBM is one only. So we will structure our material in 4 decks. Okay.
Okay, thanks. I'll send you what we have. I was going to say, I'll send you what we have with smart machines. You've seen a lot of it, Valentin, because you've been working on diversity.
Yes, absolutely. Mm-hmm.
Yeah. Okay, thanks.
Maybe we could have a soft conversation about that before you put it out, because we're using some of what we have already and we're learning things as we go. Maybe another way to ask what Dave's saying here, right? This looks, the subject of this slide kind of is a vehicle, right? But if I own 100 of them, what data can I aggregate together about the 100? Fact is they're all safe and running. That's good. How much mileage, how much fuel consumption is going on? But then add to that with a bit of map tracking, how efficient are they being with the number of deliveries they've done today? How on time are they? How erratic is the driver? How safe, all of that is the aggregate of 100 vehicles, not just one. But it seems like we've got enough data of the one. We maybe just need to think about our position point of view on it, adding 100 of them together.
Yeah, I think it depends on what customer you address. And if you cannot go with the fleet management to, a pure automotive customer like Chrysler or Teva, the guys taking the Israeli submarines charging algorithm and wanting to put them in their trucks, electric trucks. Because they want to see exactly how that truck is using its energy. Yeah.
We'll follow up with you, Valentin. We've talked to 3 companies in the last 3 weeks who are all leasing fleets of trucks, right? They're kind of leasing logistics companies. So we'll give you a pointer to there, and maybe we'll pick that one up. Anyway, sorry, let's just keep going.
Yeah. So, Dave, did I answer the question or?
Dave, you still there?
Yes, I was on mute. Sorry. Yes, thank you very much. I'm going to send you the smart machines work that we've done, like I said.
Okay, thank you very much. Thank you. Okay, digital eyes. I started to say that, we do these for Pioneer, which is the world's largest automotive safety supplier. Their corporate vision is to save more lives and prevent injuries. And they partner with us for embedded software development, integration, and testing of ECUs. For them, we're building the digital eyes, which use vision and infrared cameras as sensors and enhance day and night vision capabilities of the drivers. These cameras, vision cameras, can be mono or stereo, and they are installed there up on the windshield, and they feed real-time imagery to the ECU. And this ECU software detects cars, pedestrians, traffic signs, road surface, and then it can inform the driver about them or take the necessary actions. Infrared cameras are for situations like nighttime or even dense smog, and they have good performance, and we're handling those. A couple of digitalized use cases are here, can be found on the slides. But what is actually behind the digital eyes? To build up these digital eyes, we use our solid domain knowledge, automotive domain knowledge, and ECU experience. We do architectural design, helping them, the partners, define their system architecture using AUTOSAR standards. We do analysis of software requirements and ensure the architecture meets the functionality, the performance, the quality, and the schedule requirements. We define modules and interfaces, software operating modes, high power, low power, idle, or whatever. Then we do embedded software development, integration, and testing. We ensure ECU software performance under mandated requirements, safety standards, and so on. And for testing, we define and own the testing strategy and apply continuous integration best practices, ensure that KPIs are met. For people who need that, for customers who need that, we also offer our project management expertise, supporting the ECU deliveries right on time in scope, time, and budget. And throughout the development lifecycle, we do full coverage and implementation of the so familiar V-cycle for the automotive companies, and specific technologies that we use, and interfaces, and CAN bus, FlexRay, Ethernet that I have mentioned just a few minutes ago, Canoe. Code is written in ANSI-C. That's very typical for automotive. Python scripting for testing. Then doors for requirements management, and so on. There's a number of tools we're using. Electric drive, Chrysler Electric. That's an interesting customer. An opportunity that we have just signed, and they are the world's lightest and most efficient batteries. Used for e-mobility and for stationary storage systems. And they now started to go further into the electric vehicles arena and wanted us to help them along the way. Like I said, the electric vehicles are simple. There are 5 major components which build up the EV powertrain, where we do our work for Chrysler. It's the electric engine, it's the battery pack, it's the inverter, the charger, and the DC-DC converter. Now, these electric cars feature the instant torque delivery, which leads to huge acceleration of the line. And this torque control is one area where Chrysler wanted us to support with. And also in the charge control for AC and DC charging. So these are the 2 areas where today we are bringing our contribution. We address this electric drive functionality with the same set of skills as for the digital eyes. It is basically the same. It's ECU, embedded software development, integration, and testing. Now, Chrysler was looking for a specific part of the automotive domain knowledge, and that was about safety norms and requirements. So they specifically asked, do you guys know the ISO 262 to 262, specifically related to safety? So we gave them a show, an entire showcase and display of our know-how, and they were very happy. Also, they want to do the V-cycle. We do that. So again, that was a very good match for their expectations. Now, in addition, we also leverage our proven software development and platform engineering background. Just to recap, for the electric drive, we do design, development, and integration, as well as testing. Intelligent brain. Okay, Pioneer again. Pioneer called us to explore together ways to improve the automatic detection algorithms which are required for autonomous driving vehicles. They're investing a lot of effort in the data marking process. How does that go? They take drive-by videos taken with vision cameras, stereo, mono, and also with infrared cameras. And using specific tools, they take every frame of those videos and manually mark, okay, this is a traffic sign, that's a car, that's a bus. And use all that information, that data marking, as training data for their automatic detection algorithms. They're not happy that this process takes time, and the performance of the detection algorithms is not the one they want today. So that's when Wilbur came into place, and there was a very, very interesting discussion at Pioneer office here in Timisoara. And they were fascinated to see how much Ness knows about the topic and how advanced we are in this domain. So for analyzing visual imagery, we use deep learning, and more precisely for image recognition and interpretation, convolutional neural networks. I'm sure you guys know a lot about it, so I won't go through the basics of it. Just mentioning that the use cases we will be working on for Pioneer or scene understanding, lane detection, traffic sign detection, highway path planning. We'll see how that goes. Okay, connected vehicle. Yeah, we're moving on to it. This is here, one of our longest time digital partners. This is the Chicago-based here. For automotive area here has a number of focus areas. One is map content, connected vehicle services, in-vehicle infotainment, and self-healing maps for autonomous vehicles. Our partnership started 8 years ago, and ever since we supported them to digitally transform data flows, supporting their next generation of 2D and 3D mapping on here location platform. So here we actually add another dimension to ADAS, the advanced driver assistance system of a car. We developed a software product which extends 2D digital maps with height, curvature, and slope information, turning them into 3D maps. We also do connected vehicle services. These are automotive services for drivers and passengers, high definition live map, digital transportation infrastructure services, and so on. And we have the high definition urban map here, which focuses mostly on lanes, lane detection, lane gap filter, lane confidence automation, metrication in edit lanes workflow, and so on. Visual products and framework. Here, we deal with 2D and 3D junctions, offering driving guidance in complex motorway interchanges and bifurcations. 2D road signs also displaying a realistic representation of guidance signs on motorways. And then visual buildings, here the last one, handling illustrations of real world buildings, landmarks, providing instant recognition to the user. And also advanced, under this topic, advanced 3D city models, including road and pedestrian networks, buildings and landmarks for intuitive routing guidance. How do we do this? Okay, well, we use our traditional software product and platform engineering capabilities, doing analysis, design, development, and testing of software applications implementing map data loading, map editing, map data processing. We brought innovation in 3D rendering. There's actually a patent filed and based on the work we've done. Here, I think on car infotainment, yeah, here and location-based services integration, we brought our contribution. And also on the cloud APIs, like the entitlement API, traffic API, automotive discovery API, automotive e-commerce API, dynamic maps API, just a few of them where we contributed. Technologies that we have used. Yeah.
Valentin, quick one. I mean, don't answer it now, and I know you're digging around finding lots of this out as you go, but car infotainment is something that both NAB are looking into, potential customer and old customer, and definitely TiVo are looking at. So if there's anything you could flesh out from something we've done there into slightly more than the two words, and maybe someone that can talk to it, that would be a really useful thing to find out and kind of seed in some of these discussions. So just flagging up there, car infotainment, very interesting.
Wonderful, because you will see at the end of this presentation who is the team behind this automotive sector here. I'm supporting the automotive sales pursuit, and we have an expert, subject matter expert from Košice, who has been hands-on involved in development of all these. So yeah.
Hey, but so far you're doing a better job than anyone before you at teasing out some of these stories. So I'm going to go through you to get the story. You're our ace reporter amongst other things.
Hey, let's get some sales done together. That's the thing. Okay, so let me move forward then with big data and analytics. I already mentioned that this is not a direct automotive offering today, but we are aware of the need of big data and analytics in autonomous driving. I mean, it's estimated that for one single vehicle, only sensor data adds to 4 terabytes every day, per day, from vision and infrared cameras, radar, LiDAR, sonar, GPS. And here I'm bringing in something that you already know, guys. This is a great proof of concept that you put together some time ago. The partnership between NASA and Manor Racing to build that analytics platform, Azure-based, just to prove our capability of ingesting a massive amount of data from the race car and process it. The goals were here, just to remind, making the car faster using telematics data in descriptive and predictive analytics, and then monitor and predict car health. And it's implemented the telemetry pit wall, the race dashboard, the track view, the tire degradation model. This is a cool application. Okay. Then the extended automotive technology stack. At the lower layers, you will truly see tools and technologies that are used down there in the ECU development, integration and testing, and machine learning like TensorFlow and Keras for detecting, understanding, recognizing scenes, objects, and so on. But at higher levels, we basically put everything what we have used to make the connected vehicle possible, and also from other applications to illustrate what we can do in case our customers, automotive customers, demand for it. Now, speaking about hubs, automotive hubs, Romania, where I'm based, is seen as a true hub in the European automotive industry for a number of reasons. It's strong automotive tier 1 and tier 2 presence. There's, in the western and central part of Romania, there's high density places with counties with up to 75 companies from the automotive sector, counties. There's also an abundant automotive talent where we can choose from. For instance, in Timișoara, there is Continental, which, like a vacuum cleaner, got about 4,000 engineers under one roof. So there is an abundant talent, automotive talent pool you can work with. And also, there are academic programs offered by universities in these centers, in Timișoara, where I'm based, in Arad, Sibiu, Brașov, and Argeș. Now, there is another slide which is in preparation right now. It's the automotive footprint in India. India is also serving automotive industry as well. And the Bangalore Automotive EDC build-up is in progress with Pioneer being among our customers. So once I have that slide, I will include it in the deck.
Valentin, you should definitely provide the same slide for Slovakia as well. I was at a trade fair where they told me it was like 45% of GDP in Slovakia or something crazy like that was automotive.
Absolutely. And in Slovakia, we also have the connected vehicle component that comes from there. And they are great people. I mean, I was impressed about their know-how when I visited them and got deep dive in their project. So yes, you're right. Okay, now who is supporting you guys? It is Ketan as IoT practice head, is JP as a solution architect, Ciprian is the automotive subject matter expert dealing with Pioneer, everything what is Pioneer. He's also in charge now with ramping up the EDC center in Bangalore, the automotive EDC center in Bangalore, doing interviews and so on. Then it is Vali Lupia, who is the EDC manager doing the Chrysler work for the electric vehicles. I mentioned the connected vehicle subject matter expert. And then it's myself. So that's basically it for today from this slide. I can tell that. Yes, please.
Yeah, it's a perfect place to end. Thank you for sharing all that. It was great to have all the knowledge in one place, but let's make sure we use the rest of our time just to take any questions from everyone that heard all that. We've got Valentin on the mic. Let's grill him a bit.
Yeah, just before any question, I can tell that it is really hard to put so many years worth of work in a couple of slides. So the purpose of presentations like this is to raise attention, get attention from the customers. And once we do that, then we can get into deep dive sessions with all these subject matter experts and get down to architectures and even code if necessary. So for now, I would take higher level questions from you guys.
Did you mention Masternaut anywhere in here, or are they still a customer?
Yes, they are a customer, and that customer will be detailed. That's a fleet management and driver behavior management customer. So we thought that it will fit better into the smart mobility slide deck alongside with VIX, with smart public transportation, with Flowbird, with here again, which is not pure automotive, ECU-based functionality. So Masternaut is not here, but will be in the smart mobility deck.
So Valentin, how are you prioritizing those decks? So you've got, is mobility next and is smart machines last, as you kind of described it? Because if we get
I think I just that was the order I remembered them in. But the next one, which I actually put together and needs to be polished, it has some loose ends, is smart machines.
Awesome.
Talking about exactly what you mentioned, condition-based lighting, predictive maintenance, industrial customers. So that will be on January the 10th. And then very shortly, because that's in the works already, it is the smart mobility.
Perfect, thanks.
Okay, sure, very welcome.
Everyone seems to have been a bit shy today. Maybe you've overloaded them.
Just one bit of trivia. There was a period when automotive went through bigger changes, I think, which was a century ago, when there were three viable choices for automotive technology. It could have gone electric, it could have gone gasoline, or it could have gone steam. The Stanley steamer was set speed records at the time, and it just happens that they all ended up on gasoline because world oil prices seem to be going down, or oil seemed to be plentiful at the time. But so we've seen these kinds of junctures before. So it could be that from here, electric will be the one that takes over. Anyway, just a bit of history.
Oh, thank you. Thank you. I'll keep that in mind.
India could have been in the lead then, because they've got a lot of coal to make steam, and we wouldn't have had all this Middle East stuff.